Hi, I'm Miguel, and this is a Nerf gun.
Nerf guns are toy weapons that simulate actual gun mechanics using foam bullets. Many models have come since the original Nerf guns, from N-Strike to Elite to Vortex to Zombie to Mega to Doomlands and to the current model, the AccuStrike. So how do Nerf guns work? Well, when you pull this hammer right here, it pulls back the plunger, which fills the chamber here with air. When you pull the trigger, you release the spring holding the plunger, which rapidly compresses all of the air inside of the chamber and releases into the hole of the bullet, propelling it forward. Before we understand the law itself, we need to know the characteristics of gases. So gases, unlike solids and liquids, are extremely spread out. Most of their volume is made up of space. Because of this, there are three main properties. 1. Gases are extremely compressible, thanks to the majority of their volume being empty space. 2. Gas particles are constantly moving, and move quickly at that. If a certain amount of gas is placed in empty space, then the gas will expand to fill the space. This is because unlike solids or liquids, gases don't have a fixed volume, and so will expand based on the empty space around it. 3. On top of that, it's a well-known fact that gases take up notably more space than liquids or solids due to the fact that the majority of their volume is comprised of empty space.
Back to gas laws. What are gas laws? Gas laws are laws that exhibit the behavior of gases with different characteristics. There's Boyle's law, Charles' law, Avogadro's law, Gay-Lussac's law, combined gas law, and ideal gas law. Which one applies to this Nerf example? Well, it's Boyle's law. Boyle's law. In the 17th century, Robert Boyle studied the effects of changing the volume of a fixed amount of gas in the same temperature. He found that a gas's pressure and volume are indirectly proportional, meaning that if one decreases, the other increases, and vice versa.
For example, take a balloon. As you step onto the balloon, the force rapidly reduces the volume inside, which increases the air pressure and forces the air out, thus breaking the balloon.
Let's visualize this. If all the tin cans were gas particles and the black area is the container, the particles would spread out to fill it. If we decrease the amount of space where the tin cans could move, they become more closely packed, increasing the pressure.
Let's relate this back to the Nerf gun. As we stated earlier, the gas chamber becomes smaller, decreasing the volume. Due to the inverse nature of the relationship, the pressure increases as well. The pressure then pushes the bullet out of the barrel, causing it to shoot.
So how else can we see Gay-Lussac's apart from this Nerf example? We'll take the basketball. Take the basketball. Take the basketball. Take the basketball. The amount of pressure inside keeps it firm shape and it allows it to bounce. If it were inside the environment, then the volume of the gas would be much larger. But because the container is smaller, the pressure increases.
Let's have another example. Take the soda can. There's a lot of compressed air inside of here. So instead of using materials like, let's say rubber, they use metal to make sure that it's able to withstand the pressure. An LCV that can be integrated with this topic is commitment to excellence. Because us as achievers, as future leaders, we must strive to always surpass our limits, go as far in life as we possibly can, not unlike how the Nerf dart always flies as far as it can before falling. When we are faced with pressure, instead of breaking apart, we should instead use that pressure as extra motivation to keep going, fly higher, further, faster. In the same vein, the Nerf dart uses that same pressure to fly. The higher the pressure, the more powerful the shot.